So today we are going to talk about how we can simplify neural network code with nn.Sequential class in PyTorch. nn.Sequential provides a simple way to build neural networks where layers are stacked in a sequential manner. It allows you to define a series of layers, such as fully connected layers, activation functions that are applied one after another. This sequential class is particularly useful when creating regular feed-forward networks with a straightforward flow, like a regression neural network, where each layer's output is immediately fed into the next layer. So here we have our previous code on this particular neural network, where after the input layer, we had two hidden layers. The first hidden layer had 32 neurons, and the second hidden layer had 64 neurons, and finally we had the output layer with 1 neuron. So what we did was, in the constructor, we defined our fully connected layers, which were linear layers. Then we constructed the flow of our data in the forward method. The input we had, we sent it through FC1, which reflects our first hidden layer. Then the output from the first hidden layer is sent to a ReLU activation function. The output from the ReLU activation is sent to the second hidden layer. The output of the second hidden layer is forwarded to the ReLU activation function. Whatever the output from the ReLU activation is, that is sent to the output layer, and the output layer returns whatever it predicts. Then we return that predicted value from the forward method. So basically we designed our flow of the neural network in the forward method. Now we will be writing another class, that is neural network 2, using the sequential class. Let me take this line here, but let me name it neural network 2. Okay, now we'll be using the sequential class. So we write nn.Sequential, where we will be providing all our layers within this parenthesis. We'll capture the model from sequential. Let's name it. Let's name our model architecture. So we'll write self.architecture. Now actually we'll be putting all our layers just like as we had before in the previous class. So we have this as our first layer, so we put a comma, that is the first parameter defining a layer. Then actually we want to put ReLU activation, so we use the definition of ReLU from nn.ReLU function from this one. So this is the definition of ReLU. So the output of this particular layer will be going through ReLU function. Now the next layer is this one. So we copy this and put it here. Then we have another ReLU right here. Then actually we have this final output layer which we are copying. We have it here. So basically in the constructor, we are defining our flow of information or flow of data. Now we'll be writing our forward method. So instead of defining the flow in the forward method, what we will do is, in the forward method, we will be sending our incoming input data, this variable x, to the architecture. And the architecture will return us the output of this entire neural network. So we just return that value from here. So now we have an alternative version which is equivalent to exactly this code. So we have named it neural network 2. What we are going to do is we are going to create an instance of neural network 2. So now we are creating a neural network that uses this sequential class. So let's run the entire code. So there is an indentation error. I'm not sure if that error propagated in the next line too. So let me try to fix it. So that indentation error occurred in the next lines too. So let me check. Now it's good. So everything ran nicely. The results are almost similar as before. Practically, this neural network too is exactly the same as this neural network. We are just using the sequential class in neural network 2. The purpose of nn.Sequential is to simplify the code when defining the architecture of a neural network. Now, when do you use nn.Sequential and when you don't? You use nn.Sequential when your model is simple, especially if it is feed-forward neural network, just like regression neural network or classification neural network, where each layer is applied sequentially to the output of the previous layer. If your model requires multiple outputs, custom layer connections, or other special handling in the forward pass, you should still use a custom class-based definition where your information flow among the layers is defined in the forward method. So nn.Sequential is a powerful tool that can simplify the code for building neural networks when the architecture is straightforward. It's a great way to make your code more readable and manageable. In the coming videos, you will see sometimes I am using the forward method to define the flow of information among the layers. Sometimes I'll be using the sequential method when the neural network is pretty simple. Thank you for watching. See you soon in another video.